This is an activity you can do to investigate radioactive decay if you don't have a half-life source. It can be carried out by students even if there are under 16s in the class, making it suitable not just for National 5 Physics but also for the N5 Laboratory Skills course. Radon 222 is a naturally occurring radioactive gas formed as part of the uranium decay series. It can accumulate in buildings, either released from building materials themselves, or if the geology is right, by seeping up from uranium-bearing rocks. You can access a radon map of Scotland online. This is Cobbonshaw Reservoir in West Lothian, one of the places where there is an elevated radon level in the surrounding land. When radon 222 decays, it emits an alpha particle. The polonium-218 nucleus that is formed recoils in the opposite direction to the emitted alpha and ends up as a positive ion. Being positive, it will be attracted to a negatively charged object, such as this balloon that has been rubbed with a dry duster or a piece of fake fur. If we leave the charged balloon suspended in a room, polonium-218 will accumulate on it. Polonium-218 has a half-life of just over 3 minutes, decaying by alpha emission to lead-214. Lead-214 is also radioactive. It decays via beta emission to bismuth-214 with a half-life of about 27 minutes. Note that we won't show gamma emissions in the following equations. Bismuth-214 is also a beta emitter and decays to polonium-214 with a half-life of just under 20 minutes. We should point out that there are other decays in this series. So, after a time, the balloon should have radioactive polonium, lead and bismuth adhering to it. We sometimes call these the daughters of radon. We're going to take 4 readings of background count, each over a minute. Need to remember to take the end off the GM tube. So the average was 20 counts per minute. We are now going to gently deflate the balloon that has been left charged and hanging in our lab for about 30 minutes by snipping it close to the end where it is tied. That way, fragments don't go flying everywhere. We'll place the fragments a centimetre or so in front of a Geiger-Müller tube that's connected to a counter. If we take readings every minute and correct them from background radiation, we can plot a decay curve. It would not be right to call this a half-life graph because there is likely to be more than one substance decaying at any one time. If you have a data logger, you can get it to take readings every minute and plot the decay curve. This Geiger-Müller tube and the data logger attached to it has been supplied to every local authority in Scotland by SSERC. The idea is that it can be lent out so that everyone can try the activity even if they don't have the equipment themselves.